Hello and welcome to Algebra 2, Chapter 7, and it's called Powers, Roots, and Radicals. Today we are going to be talking about 7.1, which is nth roots and rational exponents. So evaluating nth roots. So the first question I have for you is, why is 3 squared 9? And so hopefully you would know some answer, well, because squared means you take it times itself, and so 3 times 3 is 9. Okay, and then so what is the square root of 9? And again, hopefully you know, the square root of 9 is 3, and there's an invisible 2. Whenever you have a square root, there's an invisible 2 right there. It's called the index. And what a square root is telling you is what number times itself is 9. And so because 3 times 3 is 9, then the square root of 9 is 3. Okay, so why is 4 cubed 64? Well, the basic answer is because 4 times 4 times 4 is 64. Okay, because to cube something means to take it times itself 3 times. So what is the cube root of 64? So this is asking us what times itself 3 times is 64. Well, the answer is 4, because 4 times itself 3 times is 64. And finally, why is 3 to the 4th 81? Well, because 3 times itself 4 times is 81. And so what is the 4th root of 81? It is 3. And again, because we're looking for what number times itself 4 times is 81. So there's this relationship between the 4th power and the 4th root, and the 3rd power and the 3rd root, and that they undo each other. Okay, so cubing 4 gets to 64, but then the cube root of 64 gets you back to the 4. So they are undoing each other. So, evaluating in roots, for an integer n greater than 1, remember an integer is a whole number, okay, and so greater than 1, so you're talking about 2, 3, 4, 5. If b to the n is a, then b is the nth root of a. So this is saying the nth root of a is b. So if 2 to the, let's just do to the x power is 16, then the x root of 16 is 2. And so we're just putting those numbers in those corresponding places there, okay? And n is the index. In this case, I used x to be the index. So there's a great relationship between indices, this index here at the beginning, and powers. So let's first look at the square root of a times the square root of a equals a. Well, what is another way of writing something times itself? You write it squared. So this could be the square root of a squared, or you could actually write it as the square root of a squared. They actually both mean the same thing, but this equals a. And so what's happening here is that the square and the square root, because they undo each other, they cancel essentially, and you get a equals a. So this has to equal a, and so that's what's happening, is that square and that square root undo each other. There's actually another thing going on there, and we're going to use this second example over here to figure that out. So what do you do with your exponents when you are multiplying? You add them, and k plus k is 2k. And on the other side here, we just have a. So if you don't have an exponent, what is the exponent? The exponent is 1. And so for these to equal each other, then 2k has to equal 1. And so then k equals a half. So if I had a to the 1/2 times a to the 1/2, because that's what I just figured out k was, that has to equal a. Well, that looks kind of similar to this over here, that I have these two things that are related that equal a. So hey, guess what? The square root of a equals a to the 1/2. They mean the exact same thing. And remember I talked about this invisible 2 out front here. That is where we get this 2. So you can take this though further. The cube root of a actually equals a to the 1/3. The 4th root of a equals a to the 1/4. The nth root of a equals a to the 1/n. This is a very important property that we're going to use to go back and forth between what we will call radical notation and what we'll call rational exponent notation. Alright, so a few notes here. If n is an integer greater than 1, so 2, 3, 4, 5, if n is odd, so remember n here is your index, if n is odd, then a has one real root, and it's just whatever a to the 1/n is. If n is even, so you're looking at a square root, 4th root, 5th root, and you have a number underneath that's greater than 0, then we're going to have two real roots, and so we're going to add our plus or minus in front, because remember when you take the square root of 4, you get plus or minus 2, so that's that case. If n is even and a is 0, you're only going to have one real root, and that is 0, because the square root is 0, 0, the 4th root is 0, 0. Or if n is even and a is less than 0, so you're going to have a negative under there, you're going to have no real roots, or you're going to have two or more imaginary roots. Okay, so find the indicated nth root of a. So this would say we're looking for the 5th root of negative 32. So what times itself 5 times equals negative 32? And first of all, is this possible? So if I want it to equal a negative, and these all have to be the same, if I take 5 negatives times themselves, do I get a negative? Yes, because these two make a positive, and these two make a positive, and this one stays a negative, and so I do end up with a negative. And the 5th root of 32 happens to be 2. 2 times 2 is 4, times 2 more is 8, times 2 more is 16, times 2 more is 32. So this is negative 2. So what about the cube root of 64, which we actually already talked about, right? The cube root of 64 is 4. Okay, because 4 times 4 is 16, and 16 times 4 is 64. And your calculators will do this for you. If you don't know how, please ask when you're in class. Alright, so a few more notes. This kind of, well, two things we're doing here. The first one is we can split up our fraction for our exponent. So for example, if we have a to the 2/3, that's going to be the cube root of a squared, or you can do it's the cube root of a squared. It doesn't matter where that squared goes. Okay, so that's what this first one says, that the denominator is going to pop around to be your index, and you can split it apart like that. The second one here talks about when if we have negative exponents. Remember, we can't have negative exponents in a final answer, so you're going to move it to the bottom, and then you can do that same thing with splitting them apart. So we're going to evaluate some of these expressions, and again, your calculator will do them, but you need to know what your calculator is doing. So this first one, the 2 pops around to the front, and it's the, well, it does not become a 3. Let's try that again. It's the square root of 16 to the 5th, or you can do the square root of 16 to the 5th, which I would write it like that. Square root of 16, we got that part, right? That's 4, so you end up with 4 to the 5th. Then I'm just going to use my calculator. 4 to the 5th is 1024. So this next one, I would do the cube root of 64 to the negative second. So the cube root of 64, we've talked about this one a few times today. The cube root of 64 is 4, so you're going to get 4 to the negative second. That negative second moves it to the bottom, and you get 1/16. No fractions, or no decimals anywhere on here. Everything should be a fraction. Okay, so the next one, we're looking at the square root of 49 cubed. Okay, and the reason I like to put the cubed on the outside instead of the inside is that you do need to follow your order of operations, and so it makes more sense, I think, to make the smaller number first and then cube it to a bigger number. So we get 7 cubed, and then I'm going to use my calculator for 7 cubed is 343. All right, and this last one here, we're looking at the fourth root of 16 to the negative 3, which the fourth root of 16 is actually 2 to the negative third, which is 1 over 2 cubed, which is 1/8. Okay, so remember your negative exponents move things to the bottom. Okay, so these are ones that they're not going to have an exact answer, and so you're just going to use your calculator. Someplace on it, if you have a graphing calculator, it's under math, you can find cube root or x root. For your other calculators, you probably have a y to the x button. And so I'm going to go in and find the cube root, and then I'm just going to type in 3 to the fourth. And we're going to go to 2 decimals, and so we're looking at 4.33. It's 4.3267. Okay? And then I'm going to do the fourth root of 3 cubed, and I get 3.28. Nope, 2.28. Let's try that. 2.28. Okay, and if you don't know how to use your calculator to find those, then just please ask. All right, so one more thing we're going to do, and that is we're going to solve some equations, and the main thing you need to remember is you need to get x to the nth by itself, and then you're going to undo that power by taking the root. So 6x to the fourth equals 3,750. And you have to get x to the fourth by itself, so you do that by dividing both sides by 6. So x to the fourth equals 625. And then to get rid of that fourth power, you're going to take the fourth root. So that cancels, leaving with just an x. And then in my calculator, the fourth root of 625 is 5. By the way, since we've talked about how that converts to a power a little more, why that cancels is because this fourth root is a 1/4 power. And then what do you have when you take an exponent to an exponent? Well, you multiply, so 4 times a fourth is just 1, and so that's really why they cancel. All right, so on this second one here, x plus 1 is grouped. You cannot split that apart, so you're going to go ahead, do the cube root of both sides. So x plus 1 equals, there's not a perfect cube root of 18, and so what we are going to do is we are going... at the moment we'll just leave it. We'll just leave it. Cube root of 18. All right, and then we're going to subtract 1 from both sides, and so I would write that -1 plus the cube root of 18. Okay, there is 7.1. There's another video with some extra examples if you need to check some more out. Have a good day.